Pechay and his friends. Welcome back. Today, we're going to talk about the nitrogen cycle. But first, let's start with the basics.
Nitrogen is an essential component of proteins, genetic material, chlorophyll, and other key organic molecules. It exists naturally.
Nitrogen is a colorless and odorless unreactive gas that forms about 78% of the Earth's atmosphere.
In nature as nitric oxide by lightning and ultraviolet rays, but more significant amounts of nitrogen are fixed as ammonia, nitrites, and nitrates by soil microorganisms.
Industrially, nitrogen is obtained through fractional distillation. Additionally, it mostly comes from atmospheric precipitation, geological sources, agricultural land, livestock, poultry operations, and urban waste.
Amino acids are the building blocks of protein, and nitrogen is a crucial component of amino acids which are necessary for sustaining life. Also, nitrogen is essential in the growth and reproduction of both flora and fauna.
But extensive tissue damage or burns can result from exposure to liquid nitrogen or cold nitrogen vapors. There are no warning properties such as color, odor, and taste, and excessive inhalation can cause dizziness, unconsciousness, and vomiting.
What is the nitrogen cycle? The nitrogen cycle is a biogeochemical cycle in which nitrogen is converted into various chemical forms as it moves through the atmosphere, land, and sea habitats. It begins through nitrogen fixation, which is the process by which gaseous nitrogen is converted to NH3 or ammonia via biological fixation or nitrate through high-energy physical processes.
Next is the nitrification. Nitrification is a two-step process in which ammonia is converted to nitrate. First, the soil bacteria Nitrosomonas and Nitrococcus convert ammonia to nitrogen dioxide, and then another soil bacterium.
Assimilation is the process by which plants and animals incorporate the nitrate and ammonia that was formed through nitrification and nitrogen fixation. Plants take up these forms of nitrogen through their roots and incorporate them into plant proteins and nucleic acids. Animals are then able to utilize this nitrogen through the plant tissues.
Followed by ammonification, which is the conversion of organic nitrogen into ammonia. The ammonia produced in this process is excreted in the environment and is then made available for nitrification or assimilation.
And the nitrification, which is a reduction of nitrate to gaseous nitrogen by anaerobic bacteria. The process only occurs where there is little to no oxygen, such as deep in the soil near the water table. Hence, areas such as wetlands provide a valuable place for reducing excess nitrogen levels via the nitrification process.
The rate of nitrogen fixation on land has been increased by human activities, doubling the annual transfer of nitrogen from the vast but unavailable atmospheric pool to biologically accessible forms.
Industries that manufacture nitrogen fertilizers and cause fossil fuel combustion, cultivation of symbiotic nitrogen-fixing bacteria also contribute to the problem.
The increase in human activity hastens the release of nitrogen from soils and organic matter that has been stored for a long time.
What are the effects of the altered nitrogen cycle with the influence of climate change to human life and the environment? Beginning with climate change, nitrogen pollution is a potentially more difficult problem to solve. Particulate matter and acid rain are caused by nitrogen pollution, and nitrogenous gases are also a major contributor to global climate change. Nitrous oxide is a highly active greenhouse gas.
Biodiversity becomes vulnerable and is influenced by a variety of human activities. Significant changes in nitrogen availability can cause serious alterations in the nitrogen cycle in both aquatic and terrestrial ecosystems. Increase in nitrogen can cause anoxia, or lack of oxygen, or hypoxia, or low oxygen in nearshore marine environments.
Human health also faces risks and danger. When in abundance, various types of NR can cause human health problems, especially to infants. High protein absorption can result in high urea production and an elevated blood pH, causing the immune system to overreact.
Nitrogen at higher levels causes a loss of certain plant species, depletion of soil nutrients, that of fish and aquatic organisms, and contamination of drinking water. Large amounts of nitrogen can produce pollutants such as ammonia and ozone, which can alter plant growth. The use of reactive nitrogen also plays a part in changes in land use affecting farming and food production.
The costs for nitrogen contamination in water are high, both for human health and ecosystems. High nitrate levels in drinking water can cause blood disorders in babies and increase the risk of colorectal cancer. Lake eutrophication can happen, which is nitrogen pollution in waters. This causes excessive growth of aquatic weeds and algae. Nitrogen pollution can also cause unpleasant odors and tastes, dissolve oxygen loss, and the extinction of marine organisms.
As students, we can promote awareness to people through social media intervention. We can post publication materials to catch people's attention and increase their awareness.
We can join different campaigns and organizations, creating educational videos like this about the issues on excessive nitrogen emissions can be posted on Facebook and YouTube.
We can also do volunteer work at organizations that focus on the conservation of the environment. Moreover, realizing the value of food and water conservation, as well as reducing the amount of the waste we produce.